Thanks everybody for coming to our panel tonight. The topic of the panel is coding for safety, security, and sustainability. My name's Bob Stiegel. I'm the hapless MC of this adventure. Starting at the left side of the table there is Chandler Carruth. We have Herb Sutter, Sean Parent, Daisy Hollman, JF Bastien, and Lisa Lippincott, our esteemed C++ experts. And so I'm going to ask a question to see the discussion. And that question is quickly, starting from the left, Chandler, in a few seconds, 30 seconds or less, can you please describe briefly, give us the executive summary of what the word safety means to you in the context of C++?
What does the word safety mean in the context of C++? I would really like to give more than 30 seconds answer to this. Fortunately, there's this keynote where I have like a section that I think answers this. But to give you the short version, for me, safety is about limiting and constraining what can happen in the presence of bugs.
So you gave a forward reference to your keynote. Excellent. Herb?
I agree with Sean, what he said in his talk this morning about that safety, you're trying to get correctness. You're trying to get to correctness. But speaking to the interim goal of safety, to me, the main goal I'm interested in seeing if we can achieve is a fixed 50x improvement, so 98% reduction in CVEs in 4 specific safety areas: type, bounds, lifetime, and initialization safety.
All right.
I think I gave a whole talk on what safety means. But the short answer, since not everybody was at my talk, in the context of C++, unfortunately, I think it's somewhat a lost cause. So safety, and particularly memory safety, to me ties to the frame rule, which I covered in my talk, which comes from a great paper from 2018. And you can't have any safety or any correctness properties at all in the presence of undefined behavior, and C++ is currently just littered with it. So that's not to say we can't fix the language, but as it stands today, there is no safety in C++.
I think I'm probably the single worst person on this panel to ask about safety. Like coming from a background of high performance computing where no one cares about safety. If you have a memory bug, you rerun your program. Like, I mean, I wish I were joking. I mean, I do have to care about it a lot more at Google, but like I'm a little insulated from it. I do think that I will defer to other people on the specific topic of safety, which is something I don't usually do.
So I'm going to disagree with Sean and Herb on correctness. And I'm going to say instead that I think correctness is important, right? But safety is more about fitting particular requirements around your application, right? And so for me, that's really what it means. It does mean reducing the rate of security issues. I think security is a prerequisite for safety. But I'll do, just like Chandler, I'll do a forward reference to my keynote, not your keynote, but mine, on Thursday about safety and security to explain my precise thoughts.
Okay, so I'm going to say I'm not sure I know what safety means. I do know what risk means, but you have to go outside the language to understand risk. You have to understand outcomes. I disagree with Sean in that I think correctness is achievable. It's a hard lift, but I've been like lecturing on it for years and years, and I think that if we are determined to get there, we could get there. And I do think that that Sean would say that if we have correctness, we have increased safety. There you go.
Any questions from the audience at this point? All right, well, you mentioned security. Let's talk a little bit more about security and how that intermeshes with the idea of safety. In my mind, they're sort of two sides of the same coin in a sense, but they're not exactly the same thing. So maybe you could expound on your thoughts of the differences between them and how they intermesh, and how important it is to achieve one versus the other, or are they both equally important? So somebody want to try that?
I think a good way to start to see the distinction between security and safety is to imagine a piece of software which has no security threats. There's no threat model for the software. HPC, like you hit a memory bug, you run it again. There's no security issue for the software. I think it can still have a safety issue. You might not care about that safety issue. How you want to address that safety issue might be almost impossible to say any interesting thing about. As Stacey said, like you just run it again. So in some ways, I think that's the functional difference. And the reason why you can't easily separate them in practice is because without security, you don't know what to do about your unsafety. It's kind of this vacuous thing. You have so many options, right? Security is what forces our hand. It's what like sets a very particular direction. If we want to have security, we have to do something very specific about safety, because we have to set very particular constraints and limits on what can happen when our code is not correct.
So I'll explain a bit my thoughts that I'll explain a bit more on Thursday. But to me, the main distinction between security and safety is that safety is about the program behaving in a way that's according to a specification. The specification can be wrong, but the program runs in the context of a wider environment, I think, as you were saying, where it's not just the software, it's also the hardware and the humans and the development process that lead to it, that lead to the program behaving in a way that it was specified. Right? And a hardware failure can lead to the program not behaving in a way that the software was specified to behave. And safety, on the other hand, is more about an attack surface. Right? When you run HPC stuff, you're on a giant array of computers that by and large doesn't have attackers or adversaries. And so the distinction I would make between security and safety is that with security, your adversary is smart, and all they need is one problem to get into your program and make it behave in a way that's not supposed to. Whereas with safety, it's not a smart adversary, it's random luck, right? Stuff breaks. And when I say stuff breaks, it's humans fail. They don't do code reviews correctly, they let a bug through. Hardware fails, because hardware is built by humans. Software fails in a variety of ways. And your whole CI/CD pipeline can fail. A bunch of stuff like that can fail. So it's more or less random luck that's trying to get at you. And so while the types of failures are the same between security and safety, the type of adversaries you're dealing with are very different. Right? So making something safe in a lot of ways is dealing with the potential of random failures that has a distribution in the whole stack. Whereas with security, it's mainly dealing with a smart attacker that only needs one way to defeat your entire system to get through and do something that your system was not designed to do.
I don't completely disagree. I don't 100% agree. Security has a relatively formal definition as far as being able to protect information on the system, and safety properties support that in so much as a safety property can minimize the blast radius. Right? When you talk about your software being attacked, what an attacker is looking for is they're looking for a defect in your software, someplace where the software is incorrect. And then they're trying to exploit that to extract information from the machine. So what safety properties tend to do is limit the blast radius of those defects. They don't let you get further out into the system. They either terminate the app immediately, they're ruled out by construction, so you can't have that happen to begin with. And so they're very much about kind of locking that down and protecting. So I think if you're working on your software and you're concerned about security, you're concerned with trying to get to correctness, right? Trying to fix all the bugs in your software, because that minimizes your attack surface. Every defect, right? Whether it's a defect in a safety property or whether it's a defect in a liveness property, every defect within your application is potentially exploitable. I was a little surprised by Daisy's answer about high-performance computing, because to me, safety properties are part of partial correctness, and you may not think of safety in terms of like an exploitable security defect, but I hope if you're doing high-performance computing, like doing nuclear simulations, you're concerned with getting the correct answer.
I have lots to say about that. We finally touched something I know. Yes, I did work on some of these things at Sandia that I will be careful not to talk about. But yeah, I mean, there is a lot of concern about silent data corruption, which sounds really weird in a community that doesn't care about memory safety to care about silent data corruption. And there are people that look at this specifically from like a numerics perspective quite frequently, right? You look at the numerical stability of your algorithm, and often you can eliminate probabilities of it succeeding or converging, right, iteratively, if there's some sort of data corruption involved. And you can actually sometimes approach your answer from two different directions with respect to like the way you're converging your result, such that you mitigate that problem that way also. So this is why people kind of just rerun their program or just like go in and try and fix it if it doesn't give you the right answer. But also no one trusts just one answer, right? If you get an answer that is counterintuitive, you need 30, right? You need 30 different answers determined 30 different ways. I do think like this actually brings me to what I wanted to bring up here, and kind of to what JF said, is that like this whole discussion is happening on the software surface, and the reality is that like many of our software mitigations are dealing with things that have probabilities much lower than hardware failures or physical attacks on hardware to get information, right? And I think the reality is like the connection between security and safety here is that there needs to be a discussion of mitigation. And for some domains, that mitigation is don't trust counterintuitive results. For some domains, that mitigation is run multiple copies of the code, right? Like anything transportation typically is hopefully doing something like that, right? For some domains, it's do the same thing but different ways, and if they disagree, then don't trust anything, right? But these are all things that are outside of the realm of software design mitigations that we've been mostly talking about on these panels. Now, maybe it's out of scope for this conference, but I think there needs to be an element of practicality injected into the discussion. And sometimes that element of practicality is going to involve mitigations that both address these sorts of hardware failures and imperfect software. And because you need the mitigations for these sorts of hardware failures or hardware threats, you can use the same sorts of mitigations for imperfect software. And I think that's maybe the cynical discussion of safety in programming languages that I've started to develop. But I do think we still should strive for safe languages.
Okay, I do want to say I do agree that with JF that really when you start talking about security, what you are talking about is hostile adversaries, and quite possibly intelligent, knowledgeable ones with a lot of resources. But I do want to disagree with Sean in that correctness isn't enough to achieve security. A thing that might improve the correctness of your software is to limit passwords to 8 characters. That will not improve your security, I hope. But so security goes deeper into the design than correctness does.
Hopefully I phrase that as correctness is necessary, right? So it's not sufficient in and of itself.
So Daisy said something interesting when you were speaking a moment ago, and that about practicalities. And so having worked previously in a regulated industry, we were worried about the concept of hazard, which is risk of occurrence times the severity if that thing occurred. And the product of those things we thought of as being hazard. And so we had to write hazard mitigation procedures, hazard mitigation plans. And when we talk about safety and security in the context as you've just done, in my mind, you're sort of talking about the cause, but the effect is the hazard, the actual potential of harm to human beings. So a question that we might consider, or that perhaps you could talk about, is to what extent should we have a feedback loop where we look at the potential hazard and that feeds the amount of resources we put towards the conversations of security and safety as we're building software. Chandler?
That happens to be exactly what I wanted to add a bit onto here. So I think there's one thing that worries me with some of these discussions, which is that I think that, and I've definitely done this in the past, and I think a lot of other people in the C++ community continue to do this. I think that it is important for us to really deeply talk to the active security experts in the industry when forming our opinions about C++ security, because we have not done that very well so far. Everything I'm saying up here is actually me largely repeating what I have been taught by recent conversations with security experts that I happen to have the pleasure to work with. But they're not on this panel, and that should make everyone watching this panel a little skeptical of everything we say, including myself, because you're getting this, at least from me, secondhand. And that's something that I think as a C++ community, we've got to really work to address. And I think this actually goes directly to the point of hazard. The reason why we're not seeing a lot of discussion of the hazard, right? How severe are the issues, and so on, is because the security industry is trying to tell us that it is an absolute and utter catastrophe. And they are not exaggerating, and they are not speaking hyperbolically. They are being precise and accurate. They have data, numbers. They have people who are hurt by this. And the hazard, we are so far past the hazard calculation in kind of failing to listen to the message that the security experts around the entire world have been trying to tell the C++ community, that we're seeing government step in, bluntly. And they're not doing that because they wanted to, or because they were bored, or they had nothing better to, no, they're doing this for real reasons, because experts throughout the industry are telling them that the hazard is catastrophic, and we're taking no steps. It's really hard to have a nuanced conversation with the security industry about how bad is the CVE when you've ignored hundreds of thousands of CVEs for decades, and you're not really admitting that there's a problem, right? That's why we can't get into the nuanced discussion. We haven't earned the nuanced discussion yet, because we don't have a panel of security experts yet. I'm at least including myself from a security expert, so I can guarantee it's not 100% security experts up here. But until we can cross that threshold, we need to take them at their word, right? We need to take them at face value, and we need to do our homework, and we need to get them involved, and we need to start working with them and partnering with them. And that is how we can actually address the hazard thing, how we can have nuanced conversations. Daisy, you mentioned that some of the things we're talking about have lower probabilities than hardware failure. Some do. So many of the things that we are being asked by the security industry to address are so much more common than hardware failure. It's endemic, and we don't have to wonder. We have empiric data. These adversaries that JF mentions, they are not so well-resourced that they will find difficult exploits when an easy one presents itself. right? The fact that they are universally pursuing software exploits is because it's easy and they're available. And like, until we actually address that, they're going to keep doing it. And so like, the ball is, I think, fairly squarely in our court before we can get into the hazard thing.
I don't completely disagree. So much of what you said is true, and I agree with listening and the impatience. I think what you said is one side of the coin, because listening also has not been happening in the other direction. So I take no issue with your conclusions; they're absolutely true. But what's missing is the times that we have not been listened to. I'll give you an example. So these security experts, yeah, I've been watching that spider too. Yes. I thought it was cute. What was I going to say?
Maybe he has something to say.
I apologize for contributing to that distraction. So an example, how can I sanitize this? No, so let's just say this is going to sound like, oh, they're not using the tools we gave them, which I don't agree with that argument. Yes, we've been giving them smart pointers. Yes, we've been giving them other. It has not been enough. So let's acknowledge that right up front. That's good. But saying, well, they should be using those things more is not a sufficient answer. Nevertheless, it is true that we give them tools they ask for and then they don't use them. I am thinking of a certain bounds checking implementation that we know how to get rid of an entire class of CVEs. The set class of CVEs that's the easiest to get rid of in type and memory safety is bounds checking. Joe Bialik and I sat down like 3 years ago and spent a week going through the CVEs for a year in the bounds check area, and every single one of them, without exception, would have been fixed by use stood span. Actually use GSL span, which is bounds checked. Every single one, at least in that sample. That is one category we know we can drive to zero. And yet, I won't name any names, but I do remember shipping a bounds checked span to a certain large software vendor who desperately asked for it for this reason and found out 2 years later they never used it. The not listening goes two ways. So I share that story not to say, see, they should be using the tools we give them. That's the ingrates. No, because that's a mistake that I see people making. It's like, oh, no, we're fine. We have enough tools. That's not true. But they're not. But sometimes they really aren't using even the ones that we have given them. This is not just a job that should fall on us. It's not just a job that should fall on our users. It's a job we both have to work on, and to find better ways to work together. That said, I agree with what Chandler said. I just think it's one side of it. There's some not listening going other directions too.
So,
Go ahead,
yeah, well,
Or Sean.
to comment on both of them, yeah, I think I would love to have nuanced conversations in this space. I think the reaction at this point from the NSA and the security community has been we're going to take another tact, which is kind of the nuclear approach, which is go the legislation route and try to drive it home that way. And that is not a nuanced conversation at all. And I've been told, right, Adobe's part of an industry consortium, and that I can get time 30 minutes in front of the national what's that? Cybersecurity director, right? I can get 30 minutes of his time, but I won't be able to change their opinion. I can just state, what Adobe's position is. So I don't even know how, in 30 minutes' time, to say something articulate in that space. So I don't think we have it. On the flip side, it's like, yes, C++ could be safer, but like internally, I monitor our internal Slack channel, and And it's not just that we do run sanitizers, but the number of comments that are like, oh, I figured out if I write the code this way, then even though it's undefined behavior, there's no way for the compiler to figure it out. That's the statement. And so it's guaranteed to work, because the compiler couldn't possibly figure it out. And I'm like, yeah, no, right? So, and it's not just that. It's a constant stream, and it's junior engineers and it's senior engineers, and it is just not an environment, like I say in a talk that the definition of a beautiful language, right, what beauty means in a language is how easy it is within that language to express correct code. That's my definition of a beautiful language. And as much as I love C++, it's a very ugly language. It really is. It's hard to express correct code in C++. It's very difficult.
Could I just add to when I said that, hey, we ship them something and they're not using it, I meant to add the sentence, but there is a role for us, and that is to help our users use the tools. The way we do that is by changing defaults, such as, for example, implementing bounce checking by default and banning pointer arithmetic. Then they can't not use bounce check span. And we're helping them do the right thing and helping ourselves. That's what I meant by collaboration.
So I'll say the thing that HPC people in the audience are screaming right now is that you will never get them to use bounce checking ever. Ever. Not even close. This is, yeah. So, I agree, but it's never going to be one solution for the whole industry. And the problem with that is that our industry is increasingly cross-disciplinary, right? We have things going on that are scientific computing that are touching on safety critical industries like automotive simulation, right? And the people who are going to be experts in scientific computing are not going to use bounds checking ever, period. They will change languages before they turn on your bounds checker. They will rewrite their whole code. These are people who won't move from Fortran because they think that Fortran is faster. Right, so I think that there needs to be a broader discussion of more than one solution for the same problem, and no absolutes in the discussion, I think. And I think that's a hard discussion to have because we necessarily, as experts, at least most of the people up here, myself excluded maybe, are so focused in a very specific area that it's easy to forget that some other area that's completely off our radar has a very different approach to things, I think. I also, going back to a comment made earlier about tools and about the word sanitize, I think that if you're not assessing the cost of running sanitizers in production versus your threat model or versus your hazard cost. If you don't know those two numbers, then you shouldn't rule out the idea of using sanitizers that may cost runtime performance. So I think that far too often there is an assumption that something that costs X runtime performance, X percent, is too much no matter what it gets you. And X could be 50 in some places where you really need security. So X could be 50X, in cars. I think that there needs to be a discussion about giving a performance. So I'm contradicting my first point. But there also needs to be discussion about crossing industry boundaries where people aren't used to certain constraints, working with people who are not used to ignoring certain constraints.
Okay, we had our first audience question.
So anyway, I'm Robert Secord. I'm a C and C security expert. And in the 40 minutes I've been waiting to ask this question, I've really enjoyed listening to the panel's discussion about how you should be listening to security experts. Anyway, my question's about safety, and it's, is it possible to have safe systems that dynamically allocate storage?
I mean, it depends on your definition of safety. One of the problems is we don't have broadly, so across industries, a common definition. In computer science, you'll say there's memory safety, type safety, threat safety, right? Like that's what computer scientists mostly talk about. And in safety critical industries, it's just functional safety, which I think goes back to your original question of doing a hazard assessment and risk analysis, which is it's a thing. Like Google it. It's like not a just hazard assessment. We'll just wing it. No. Like it's a thing. And so I think when we talk about safety, we don't talk about the same thing. And that's a fundamental problem that already we've shown disagreements on, because we don't actually have the same definition, which means we reach different conclusions from not the same point. So we're just not talking about the same thing. So when we talk about memory allocation, that's mostly, I think, in safety critical systems. And the rule, by and large, is don't do allocations. It doesn't mean you can't allocate. It means that you have to have deterministic allocations in particular circumstances. And you can allocate before a certain phase and not during a certain phase. And allocate means like within a certain pre-allocated thing that you know you won't run out of, or if you run out of, you just trap and then go to a supervisor system or whatever else. So you have to do a hazard analysis and threat assessment to figure out what happens if you run out of that pre-allocated memory. So yes, it's possible, but it depends on the circumstances, which is the core of what we've been disagreeing on for 40 minutes.
Yeah, I think specifically, yeah. I mean, safety can mean a large range of things. And if you were at my talk, just Googling memory safety, you'll get 50 different definitions. And yet legislators are writing it into bills with no definition included, as if it were something that were well defined and had strong meaning. And so my kind of statement on this stuff is in the same way where in these critical industries, you do have strong definitions. And in academia, there are strong definitions. But we need to kind of figure out, like, axiomatically, what properties is it that we're talking about are important to have in our programming languages? What properties does a particular programming language uphold, and how does that compare to another language? And how does that then tie in to CVEs and what's actually exploited, right? Which unfortunately is probably way too nuanced of a conversation. but ideally, that's where we get, like, Herb's goals of cutting things by a huge amount, I think, are great, and I hope he's able to achieve that. What I would like to see is he always says he's ruling out proofs. I actually think he's close to being able to prove a number of significant properties in CPP2. So I want to encourage him to learn a little formal methods and turn that into a goal. Right. Read what some of these things are and make it concrete and nail it down.
Can we define CVE for maybe someone who may not know that in the room?
There's CVE is a database of reported security vulnerabilities. And the security experts will tell you, and I'm sure they've told Chandler, that CVEs is a horrible metric. Because for many reasons, including it's only the ones people actually reported, and people have incentive not to report. And it's a horrible metric. The reason it's used all the time is because it's one of the only metrics we have. So we use it anyway. Common vulnerability enumeration.
I suspect that is not the only one in the room who did not know what CVE stood for.
No, it's run by Miner.
Oh. I do want to give one anecdote. Sorry, one anecdote is, despite us not agreeing on what safety is, after your talk where you presented a paper about memory safety definition, Chandler and I and you were talking, and we all were going to present the exact same paper in our talks. So despite not always agreeing, there's particular things that we do agree on, I think.
Okay, Lisa had a...
So to address the question, I think it is absolutely possible to write programs that use dynamic allocation and yet have a provable limit on how much will be allocated. It's also possible to write programs that use dynamic allocation and provably fail gracefully when allocation fails. So, yes, possible.
So we actually have a question on the Discord channel now from Jeff Romer. Question for the panel. If we can't agree on what safety means amongst ourselves, let alone agree with other disciplines, is it constructive for us to continue using that word?
I do have a statement on that. Does seem like no one knows what safety is, but everyone seems to agree that Rust is a memory-safe language. I don't know whether or not that fits everyone's definition, but seems to fit Congress's definition, apparently. Can we maybe elaborate on what that means specifically?
Chandler?
The security industry does not have the confusion that this panel does.
I will say that when I've talked to language experts outside of this panel and across companies, I was dismayed to find out how much disagreement there is on defining what safety is. And that is one reason why, although I'll use it as a heading in a talk as a general goal, whenever I'm specific, I currently don't use the term safety. I just say, these are the 4 things I want to reduce by this much. Because just to say safer begs these questions and still has these discussions, which is dismaying.
Lisa?
So I will say that I said earlier I don't know what safety means. I do actually know a definition of safety, which is risk to humans. But that is clearly not what we're talking about here. And I think that we do not do ourselves a service by using the word safety in this context.
Teamer, you had a question. Bob, could you hand Teamer the mic there? He's been patiently waiting.
Yeah, hi. Sorry, I hope I don't throw too much of a curveball here, but I want to kind of double down on Daisy's earlier point. So a lot of people, including several people on the panel, I think have said things along the lines of the safety problem being an existential threat to C++, and certainly I take that seriously. But isn't there another thing that is also an existential threat to C++? Like, HPC is not the only industry that's in the boat of choosing C++ for performance and not really caring about any of the safety stuff, or UB to the degree that the people talking about safety here do. Like, the video games industry is a big industry which doesn't care too much about these things. They do care about performance a lot. Music tech, there's many, many other industries that just don't have safety as one of their top 3 priorities. But what they do care about is they use C++ because they can do all of these bit fiddling tricks that are UB or whatever to squeeze the last millisecond out of their code. And it feels like if you make that harder for them, they're going to leave C++. And it seems to me that that might even, I don't have numbers, but that might even be the majority of people who use C++. And if you make it harder for them to squeeze the last bit of performance out of their code, they're going to stay on the old standard, or they're going to go to another language. They're not going to use any of this new stuff. And it feels to me that if you make it harder for them, that is also an existential threat to C++. And I wonder if anybody in the panel shares that opinion.
I think there's 2 parts of that. One is can you get the performance, and is it more difficult to get the performance? And I think in both Rust and what I've seen of Swift, you can get the performance, but it's harder. It is more difficult for a human to reason about. And Swift more so than Rust at the moment, at least anecdotally from what I've seen. So that's a challenge. And I don't know if Rust is an answer here, though, because I don't think that Rust has crossed the threshold. Like Herb said, it's only 1% of the users. And Haskell is a very safe language, but has very poor adoption. It has very poor performance characteristics, and it is a very difficult language to reason in. And that is true of most functional languages, right? There are, I think there's a small percentage of the population who thinks functionally well, and it is a difficult thing to train. And everybody in the functional industry is like, well, I get it. It's super simple for me. I don't understand why it hasn't caught on in 50 years. Right? Maybe you're the exception. One of the reasons why we started the VAL project is we have this hypothesis that the VAL model, which is in some ways equivalent to the Rust model, is a simpler model to understand. The only evidence we have from that is that VAL is based off of Swift, and what we've seen from Swift is that Swift is relatively easily adopted. So even this notion of the strong safety that you get on structs as opposed to using classes, and one way to think about VAL is kind of Swift with classes removed, right? You only have structs, you only have pure value semantics, top to bottom. There's a little more to it than that, but that's the initial hypothesis that we'd like to prove out. So, I don't think that those people will ever abandon C++. C++ will never go away. COBOL is still with us, right? Right. So there needs to be a continued investment in C++, and I think there needs to be a continued investment in making it better and pushing it forward along these things. The question is just how much of the industry gets pushed out of C++. And I think that's going to be difficult. And I think, I work on a photo editing product. What are our security concerns? We have some small ones around leaking user information. We could mitigate that by moving it into another process and writing that component in Rust. And we have very high performance guarantees that we want. But we also have a scary number of software defects in our product that we would like to mitigate and address for our customers. And so we're willing to invest in that so long as it doesn't cost us performance in critical areas, which means maybe less C++.
Let's take one more comment, then we've got a bombshell question from Hannah.
I'll be pretty brief. I just want to really try and crisply answer this because I think there is an even more crisp formulation. If this performance and safety are truly incompatible in intention, right, then the division that you're talking about is a serious risk. I don't believe they are fundamentally impossible to resolve. And that's why I don't think that they're such a serious risk. And I think that the safety side of this is a greater risk. And here when I say safety, I mean specifically the memory safety cited by security researchers, not some other definition of safety. But I think that is a critical risk because we have added numerous memory safe languages that make different trade-offs that are not in the performance critical space. And we have clear, unambiguous demonstration that that is insufficient to the task, right? That we have sufficient risk that governments feel the need to step in, that there's this like really widespread issue here. And so from that perspective, I see this differently. If we were to bifurcate the performance people and the safety people, I think that would be bad. I also think that's avoidable, right? I don't think that that is a necessary thing. And I think most of the efforts to pursue safety in the context of a C++-like language or in C++ itself are always operating with the idea they have to retain the performance critical users. And I hope that continues to be the case.
Quick example. I agree strongly when Daisy said this. Bounds checking should be on by default. I said by default.
Okay, so Hannah has asked a question. She's directed me to ask the panel, and this is a bit of a bombshell, so try and keep it a reasonable length here. What differences do you see between the many possible successors of C++, and she names Carbon, Val, Rust, CPP2 Circle, in the context of security and generally? So there's a big topic. Well, which day? Yeah. So let's offer some quick opinions if we could. Why don't we start down here and
Yeah.
start with Lisa?
Okay, I'm almost going to cop out of this, but the biggest difference that I see is that Rust is what I consider an adolescent language. It is working its way to adulthood. I think every other language that you mentioned is either in its infancy or not even really born yet.
I would agree with Lisa, and I think the implication of this is that the ecosystem for tooling around those languages is as mature as the language is. So childish languages, I'll call them that for now, have childish tools around them. They're not well known, and the training for people around them isn't great, right? But it can get better, and Rust is slightly better. I want to give one example where my company has worked with a company in Germany called Ferrocene, working to certify Rust at ISO 26262, which is a safety standard for automotive. And that requires a tremendous amount of work in specifying the language and having tooling around it. But it's not sufficient to adopt in safety critical industries. Despite Rust's advantages over C++ being a language that's been created knowing the mistakes of previous languages and having a lot of advantages on top of it, the fact that the people and the tooling and the industry around them and the regulations around them aren't mature enough, it's still in adolescence, makes it a problem for adoption still. Whereas C++ does not have that problem. C++ has many problems, but we know them. That's a critical aspect. We know those problems. We know them for C. We do not know them for Rust, for Carbon, for Val, for Circle, and so on. And it's not that they can't get there, right? So we can't just rest on our laurels. I do think there are potential existential threats to C++, but I don't really care. Like C++ is a tool, right? I'm not married to C++. The other ones can get to the point of maturity that C++ and C have. So I think that's the fundamental difference of the maturity, but it's not just the language, it's everything around it.
So yeah, I completely agree with putting Rust in a different category. I think that there are a set of problems that need to be solved for Rust to be a C++ successor, and if they get solved, then Rust will win, and that's going to be the end of the discussion. If they don't get solved, then these other languages have a chance. But honestly, I think that's where the discussion starts, for sure, for me. And some of them might not be solvable, but I do think that there is one thing, and I'm definitely not tooting my own company's horn. I would say this if I were not representing Google here. I think there's one thing that one of these languages, these other languages, Rust aside, is experimenting with that none of the others are. And is very specifically experimenting with it and very intentionally experimenting with it, and that is building community. I think that there is accidental community around many of the other languages. I'm not trying to direct this as criticism at anyone in particular. I just don't think that any other, correct me if I'm wrong, but any of these other languages have hired consultants to build community. That is the thing that Rust has over all these languages already. And experimenting with that axis, I think, is critical to success of any of these successor languages. And being intentional about that experimentation rather than organic. Because organic community is not going to, you're not doing a controlled experiment, right? You're not trying to understand the community building aspects of a programming language, because you're optimizing these languages on a very, very flat surface for junior developers. Yes, we have like, oh, this is way better than that, right? When we are experts up on the stage and know about certain things at very, very large scale software or very, very safety critical software. But for most programmers in most of the world, this is a very, very flat optimization surface, and community is the one thing that is not flat at all. And so I won't say which language is experimenting with community, but I think many of you know. And I am very interested to hear.
You're talking about Rust, right?
Well, no, Rust, that's exactly the reason why one of the successor languages is experimenting with community, is because that is part of what's gotten Rust so far. And I would be interested to hear about some of the competitors to this language that I am talking about and what their plans are to experiment with intentional community.
I'm going to say it. She's talking about carbon. And honestly, I don't know beans about community. I don't know if building an intentional community is something that's important or even works, but I am fascinated to find out.
Yeah, so I have to agree that like today, Rust is the only thing mature enough to really consider. Swift is probably a close second. I'm going to be a little blunt about Swift, which is that I think their governance model and their community model right now is a problem, which is that Apple continues to hold the reins just a little too tightly on Swift. So it's difficult if you're trying to get a change into Swift that's not important for the Apple ecosystem to land it. So, those are the adolescent languages. Everything else has a very slim shot. I think it's unfortunate that, Carbon is looking at safety right now as a bit of an afterthought. We want to get to 1.0 and then we're going to get to safety. Well, I think safety is like security, which is you have to design it in from the start, along with compatibility, or you're not going to get there. Val is riding a little bit on the coattails of Swift as far as where Swift is going with trying to get C++ compatibility. It certainly is not. Swift is way ahead, and the Val story is not as strong, and the Swift story is not as strong as what both Carbon and CPP2 are trying to go after. Val is basically a 1.5 person project at the moment, and the one person is a postdoc who's about to run out of funding. So if you have some way to fix that issue, I would like to hear about it. But our intention, Adobe's intention of investing with Val, has been to vet the idea of value semantics and some specific ideas there that we think are important, and to try to influence the other language efforts. And I think to that effect, we've had an effect. We've had conversations, I think, with all of the successor languages, and we've had some amount of influence. So in that respect, I view Val, including C++ itself. And so in that respect, I view Val as being valuable. Okay, it has exceeded my expectations in the impact it's been able to have as a very immature research project. Both CPP2 and Carbon worry me in that they are largely reference semantic, pointer-based languages, with shared mutability, which is Swift and Rust are not in that space. And I think that's one reason why we see a significant reduction in actual defects in code that is converted to both Swift and Rust. And I would like to see that addressed in both CPP2 and Carbon, and not as an afterthought. I think Carbon is in a more difficult situation as it stands than CPP2 right now in that regards. I think Herb's project, and Dave and I have been having this conversation, and I keep encouraging Herb to listen. I think Herb is like this close. He's this close to being able to have that, to match the capabilities of Swift and Rust in CPP2. And I think there would be huge value in getting there. That said, working in a language like Swift or Rust is a bit of a mind warp. You have to think about your problems a little bit differently. And so it runs into the problems that Timur was talking about, which is it's a more serious recast of your problem to get your code running in these environments. But some recast of your problem is necessary regardless. So So that's my statement.
All right, well, thank you. Herb?
Most of what I would say has just been said, and the last half hour of my talk, 2 hours ago, said it, so I'll leave it there. I'll just say I'm in favor of experiments, and I mean it when I say I like all these experiments, and I hope that we learn from each other. That's a lesson in life. I certainly hope that the most important thing we learn in life is how to listen and learn, and to apply. And so the more we can, and I've enjoyed our conversations with Val and how those things map to CPP2. And if we can learn from these experiments, then whether they succeed or not, they will have succeeded, because we'll have advanced all of us. And that's a kind of community and a kind of learning that I think is really important and hope keeps happening.
Yeah.
I have no bias at all here. None. But fortunately, I have some time where I'll talk to you all about carbon. I'm not going to really talk about carbon here, because that would just be a waste. I want to actually talk about all the other options, because I think that's more interesting. Lisa, I love the way you opened this with the kind of very straightforward maturity analysis. The only quibble I have here is, I think we are underestimating the maturity of Rust. I think there are dimensions in which it is very much an adolescent language, and JF, you bring up a great example of one. Rust is getting a lot of traction in a lot of parts of the industry. I think it has crossed the adolescent threshold. I think it is a full functioning production quality language that people are going to be shipping and writing software in for the foreseeable future. I will wager any sum of money Rust will outlive COBOL, okay? Mostly because they'll both end at the heat death of the universe. But seriously, I want people to really give Rust the respect it's due, because I think it is actually that mature. And it was clear you were including Swift in this list, but I just want to say that Swift is nowhere near an adolescent language. Swift is an incredibly mature language with an incredibly complete ecosystem, tooling, everything, you name it, for Apple platforms.
I'm sorry, Swift was on this.
There is, but there's also really tremendous work on the non-Apple platforms, and I think that, again, it would be a mistake to underestimate the maturity and the degree of adoption that Swift is seeing in the world. Okay, that said, I don't think that Rust is an especially interesting successor yet. It's a very good language. It's a really good language. But in the specific job of allowing me to move a body of programmers that currently write software with C++ over to writing software with Rust, that is an extremely difficult prospect for me to do right now, especially at scale. At small scale, it's doable. It's really hard at large scale. There are some efforts to fix this. I have some amazing colleagues that are working on trying to pull that gap in. But I think there are some also really difficult problems along that path. And to a certain extent, I don't see that as Rust's reason to exist. Rust exists for its own sake as its own language, and that's a good thing. I don't begrudge it this. I think it's a fantastic language in its own right. In some ways, I think Swift is making a more kind of concerted and end-to-end effort to address the needs of C++ programmers. John had an excellent talk covering all of that. And so I would actually kind of point that differentiation out. And then you get to kind of successors that are really trying to get very large scale, very pervasive adoption by current C++ developers. And I actually think that's a much smaller list. I think it might be a list of 3 things. I'm sure we could talk about CPP2, we could talk about Carbon, but of course the third one of that is C++ itself, the next C++ version, right? And that's actually the incumbent, right? And I think when people hear existential threat, when people think about these successor languages, I think they get what is maybe an unfortunately dire view of the world. This isn't like an existential threat tomorrow, or in a year, or in 2 years, right? When we're talking about this, we're trying to plan for 5 and 10, maybe even longer time horizons. And so on the kind of 5 to 10 year time horizon, I think there is a real concern, and we do need to be thinking about it. But just to be super concrete, there will be at least 1 and probably 2 C++ successors in that time frame that are the incumbents. It'll be C++ 26 and then C++ 29, right? And so maybe that gives you an idea of just what kind of time frame we're talking about. We're talking about multiple major standard versions out before this is really going to happen. And so in that sense, absolutely these successors are in their infancy. They should be. We've got a long road ahead of us. And that's to be expected, right? And people shouldn't worry about the fact that they're successors. C++ 23, C++ 26, all of these are going to come. They're going to be fantastic. They're going to be wonderful. They're going to address the needs of current C++ programmers, right? This is not like an impending disaster for me, the C++ programmer. This is an impending thing for me, the C++ language designer, or me, the compiler implementer, because I am forced to think 5 and 10 and 15 years out, right? I'm trying to get ready for what you will need in 10 years. And unfortunately, my lead time is 10 years. So I have to start thinking now. But that doesn't mean it's going to impact anyone now. And I just want to be kind of like super crystal clear about that. I don't think anyone is under any illusion that these things like materialize overnight or suddenly or without kind of a reasonable amount of time to go and actually make good engineering decisions and have good options available.
Okay. We had a question from the audience.
So I wanted to pivot back a little bit to the interdisciplinary conversation that we glanced over. Every time that I see these conversations, it reminds me of the Uncle Bob's talk, where he says that if we don't get our shit together, the lawmakers are going to enforce it on us. And he said this, I think, like 15 years ago or something, and we're there now, and we didn't get our shit together. And so the question that I have is, a lot of this is part of the maturity of the development process in our industry, right? Like we have tools, we have address sanitizer. Okay, it's not going to be used in production, but are we at least running unit tests with address sanitizer on? And my question is there a space like for WG21 as the steward of the C++ ecosystem to take a more active role into promoting maturity models for C++ development? And since we're talking about lawmakers making decisions, and there was the talk, Sean's talk talked about negligence, and if we frame this in terms of maturity model and say, if you're a company that is developing this kind of product, you need to be in this maturity level in your development process. Do you think there is a space for WG21 maybe, or maybe a different organization to play that role?
So, well, I was going to say, if I had to make a conjecture on like what happens when legislation passes and it will have some time frame and things will move forward, is the model within the software industry will follow much along the same lines as the model in current critical software industries like the automotive industry, right? Which is to say, you're going to have industry bodies that come up with best practices and come up with guidelines and come up with rules, and part of that will be standards bodies and so on. And the way that you're going to mitigate your liability in this space is you're going to demonstrate and get certified that you're following a well-established process.
And I can just testify to that fact coming from medical imaging, that in medical devices and medical imaging specifically, where software was not originally considered to be a device, and in the 90s the FDA realized that, hey, software is going to be a thing, and we need to start thinking about software. And the FDA actually published in the late 90s a set of guidances about software development processes. Not software itself, but processes for developing software. And it's some of the best software engineering literature you can find, and I highly recommend go to the FDA website and look up process.
Yep. And we think about this as being somewhat silly for consumer software, but it's no more silly than having, you know, your plug-in charger getting UL listed, right? That's a consumer product, and there's a certification protocol, and there's a certain safety bar that has to go along with that. And so you have to comply. Really quick before I hand away the microphone, I totally forgot, part of Hannah's question was Circle, and nobody commented on Circle. So I wanted to make a quick comment on the Circle language. Sean Baxter is Circle. It's his project. It's a closed source project. He's done amazing things, but Circle can't go anywhere unless Sean sells it or open sources it, and it just can't. No company will invest in a closed source tool that one person owns. Okay, and so Circle could be something, if somebody in this room who has enough money can buy it from Sean and open source it.
So 2 quick things. First of all, the thing that I think maybe Bjarne would say if he were here is, C++ went through this before in the 90s with governments trying to legislate away C++. It's not exactly the same, I'm sure. I know it's not at all the same. But it is nonetheless it has not been entirely free from government interference in the history of C++. This is a different scenario, but let's not assume this is unprecedented entirely. Secondly, am I allowed to say whether we run ASAN in production? Jim?
I don't know what you're about to say, so it's very Are you allowed to say the thing you haven't said yet? Maybe.
I mean, yes, people run ASAN in production. People who care a lot about performance run
Yes.
ASAN in production.
There's vulnerabilities with it, though.
Yeah, sure.
So I think Sean's right that, some software industries, automotive, medical, nuclear, defense are regulated. And what some governments are looking at today is in the vicinity of what those other industries have. But it's not novel to software. So I'm originally a mechanical engineer, and it's not just chargers getting UL certified. You buy a bolt. You're all sitting on chairs, right? How many screws and bolts are on your chairs? And they're all standardized. And software has effectively none of this, except in safety critical industries, right? So with all the brouhaha about governments coming in being you're not really serious, kid, I think they're right. Governments realized early on that software was critical to particular industries and put in standards. It's different per country, but there's kind of globally accepted things. Those standards are onerous in certain places, and they're more descriptive than prescriptive, and so you can still deviate from them, and you can make a case for I did these things, and this is why I think it's good engineering. This is what a real industry does. I'll give you an example. I live in Tokyo. The building I work in is 18th floor. I work on the 18th floor. Tokyo has mild earthquakes. Just biggest metropolis in the world. Giant skyscrapers, giant earthquakes. And nobody thinks about this until I give them this specific anecdote. Have you ever thought about, I'm in a building, it might fall down any time? I mean, I don't want to stress all of you out, but, it's a thing. And, buildings just kind of work. Now, it's not that they never fail, right? You've probably all learned in school about, particular failures for buildings or bridges or things like that. You've learned about some in software as well, right? But the difference between the two is that when a safety critical physical system breaks, the industry learns from it. Can you imagine, if you worked on Challenger and you had the people who did the inquiry looking down and being what happened? What'd you do? Right? That inquiry was a big deal. We don't get that in software. We just don't. It's because people assume software is kind of brittle, it's kind of broken, whatever, because we were talking about languages being immature. When was and this is not like a nerd's night. Who here is older than the first real programming language that had like an optimizing compiler? Like, does anyone know what the first kind of real programming language was? Fortran 66. Fortran was created in 57. There are some people in this room older than the first programming language, and we're talking about the semantics of programming language, and it's a thing that was created. I worked with someone at Google who had his PhD in parsing. Like, you're all laughing, but like parsing is like a thing that was revolutionary when he got his PhD. It's a big deal. The fact that this whole industry is new is normal, and it's maturing. The fact that governments are looking and saying like, it's causing a lot of issues, and we've regulated other parts of the software industry, it's worked pretty well. It's not perfect, but it's worked well. And we should look at other places because it's still causing issues. That's good. Now, we don't want it to be overburdensome. I think there's a fine line between having good regulations that allow you to be serious and do a hazard analysis to make sure that you invest in the places where it matters and don't invest in the places where it doesn't matter. But I think at the end of the day, it's a good thing.
So along these lines, you've sort of led, Herb, quickly?
So I strongly agree with that, and go see JF's talk. And I also agree with Daisy and Bjarne. So you were exactly correct when you said we've been here before there has been legislation to use other languages before. The reason I push back, and I did so also with Bjarne a year or two ago, said that this is different, is because, so what they're talking about is when Ada was mandated for defense systems in the United States Department of Defense and in NATO countries. It wasn't just the US, it was also other NATO countries in the 1990s. The difference, and it's subtle, but I think it's really big and fundamental, is they were the customer. They were saying, we said we will use Ada for our systems. They were essentially talking about ordering their departments, telling their departments what software they're going to use internally. It's just the government's real big, so internally. What's new now is legislation across the industry telling industry broadly what to do and assigning liability. And that is different. And so, although there are some parallels, it's just why I push back, because I don't want to, because if we say, oh, this is like the 1990s, we've been here before, and if that's all we say, there's a temptation then to take it not so seriously when this really actually is qualitatively different, because it's there they were the customer. And here, they're now the government. And it's not just US, it's Europe. There are bills going through in EU and in US for shifting liability onto software vendors.
So this actually brings me to, we've touched on process and the decision to adopt better process, better practices, which are, in my opinion at least, necessary in conjunction with the languages and the tooling. You must have good processes. You must teach people how to do things. Good engineering, right? And so that actually leads to a good question that came from on Discord here from Peter Van Sant. There's a lot of seniority on the panel here tonight where security could be made an organizational priority by fiat. There is C++ development where deadlines are set by non-programmer decision makers too tightly to fix known bugs. Where do we go from here when some of these security and safety techniques would only further illuminate the degree to how broken our shipping software is as a result of economic decisions made by non-programmers? So here's our chance to beat on management.
I'm ready, and it's because I'm not going to beat on management. I'm going to actually I'm going to kind of support management here. So I think this is actually a really good question, because we lose sight of how we actually map this into the business that software companies are involved in. Well, not everyone here writes software for a software company that's a business. A lot of us do. And I think this is important. Like, we have to actually get this instilled as a fundamental business necessity. And in my opinion, this is also one of the reasons why what JF mentioned as being a good thing is a good thing. This kind of maturing of the software industry and the government participating in that, I think, is one of the things that is going to allow software businesses to internalize that they can't afford to do this, right? That they actually have to set real, very specific business criteria that they will meet in order for their product to be viable. And I think at a very basic level, you're never going to win an argument with management about why you need to work on safety or security until they have a specific business need to achieve that. If you try to go and like talk to them and you're like, but it's a good thing. You're right, it is, and it doesn't matter. That was not the question they had. They were trying to ask you like, help me explain why we're spending money on this. And you need to come back to them with money, right? And I know that's hard. It's hard as a software developer to do this. We've got to practice this. How do we make a business case, a product case, a feature case around safety, around security? Government regulations can help. Relating it to other industries can help, right? Relating it back to product functionality can help. But we've got to actually put the management hat on and the business hat on and work with management. Because right now, they're sitting here looking at this like, look, I don't know anything about the software. I do know about the business. You're saying it's 50% more expensive. No. Like, and then we're surprised, like they don't know about the software. We have to help them. Like that's on us, right? That's our role in this, right? Is to go and help them understand how safe and secure software can make for a better business strategy.
I think, Chandler's absolutely correct. And inside even trying to make the business argument, which is to say, we're going to hit a point, we know the legislation is pending, we're going to hit a point where we will have liability, whether this will cost us money. We also have all the stats on our current software defects. We know what that is costing us. And I can make that argument and I can bring it to our senior management, just hypothetically. And then I get the answer, ooh, AI, this is really shiny over here. Okay. You want to hire 2 people? Well, if I hire 2 more AI researchers, I would make all of this money. So it's very difficult. It's very difficult to make that case. And unfortunately, I think, I want Adobe to take a leadership role and get out in front of this. And I'm hoping I can get Adobe there. At least my team is funded. But I suspect as an industry-wide thing, the dominoes aren't going to fall until there's some high-profile cases. And as soon as the legislation passes, oh, you bet the lawyers are going to be looking for those high-profile cases, okay? And those companies in the industry to slam. And if you're in a small company, don't worry about it. If you're in a Fortune 500 company and you have deep pockets, worry about it. So.
I'm going to pull a Sean Parent and take the mic along the way. Sorry. Yeah, that was unfair.
That's what I'm going for now, taking the mic along the way.
Sorry. I want to say what I said earlier, and that is that in many areas we're just going to have realistic mitigations in place. And we're not going to be able to write things in safe and perfectly safe programming languages when safety criticalness is not either legislated on us or, intrinsic part of selling the product, right? For simulation, I don't think it's ever going to matter. For scientific computing, for audio, like Timur brought up, for video games. These are huge industries, right? And the vast majority of video game software can be isolated to the security critical parts and non-security critical parts. Whether or not they do that, that's a matter of regulation, but that's not a matter of cost, really. It's not a huge matter of cost compared to what we're talking about on this panel. So I think some realism in this discussion probably is good for wide swaths of the industry. That doesn't mean that it's not important for large portions of the industry also. Right?
And I'm not disagreeing with what Chandler and Sean said, but I think it's a part of the view from pure software industries. When you work for an industry that doesn't just do a pure software product, and in some cases that's regulated, it's not that hard to make a safety case. And in fact, that tends to come from management who are not technical. I'll quote this, the now former CEO, but now chairman of our parent company. The priorities of the company are, and that's just not just for software, for everything. Number 1, safety. Number 2, quality. Number 3, volume. And number 4, profits. A little asterisk, profits, so that you can pay taxes. This is not a hyperbole. He said it many times. It's publicly recorded. And when there is a safety problem, because it happens, companies mess up. It happened fairly recently. The guidance in public is do not lie, do not distort the facts, do not run away. And I think that's a very big difference from, I've worked in pure software industries before. It's a very big difference, right? Like the motto, move fast and break things, didn't come out for a random reason. It's that you can fix in production. It's true. If you have a memory leak, you can just reboot the server. That's the thing, right? This is not theoretical. There's companies that just run their servers until the memory is full, and then they reboot it, or deploy a new version, and then you reboot anyways. And so I think what you were saying is right. Well, yeah. But that's part of the hazard analysis, too. In an airplane, if you've determined that after, 200 days, you need to reboot your airplane? Sure. It's part of the hazard analysis. It's totally fine. Because they've analyzed all the other things that come out of it. So we make fun of it, but it's a mature reaction to a problem you discover later on. And so I think what you were saying earlier of like there's these different industries and trade-offs is exactly what we need to understand as well, is different industries are different levels of maturity in dealing with these things. And I think I agree, gaming will never really need to care about most types of vulnerabilities. I think that's true. But I think other industries will have to care, and that's where what Sean was saying is right. There's going to be bigger targets on some of them, right? Just because like you want to set an example of like, well, we've been telling you it's going to be a problem. It's kind of now a problem, and you're the first one to mess up, right? So I think it's a thing that you want to be ahead of that change and not be the head of that change.
So. Just wanted to make a quick comment about an article I read a few years ago before I get on to the final 2 questions. So I think it was in IEEE software or communications, the ACM 10 or 12 years ago. There was a guest editorial, and the writer posited that we should take our technical debt and value it and put it on the general ledger. And I thought, this is a great idea. And if you made CFOs do that, there would be a whole slate of heart attacks. All right, so enough of that. There's a very interesting question here, which I think perhaps Robert Secord might actually know the answer to. Do we know what percentage of the MITRE CVE database is directly related to C++? Or does anyone Robert or anyone on the panel have a feeling for that?
One of the things I'll say is that a lot of security people have administrative backgrounds, so for many years, a lot of security people have administrative backgrounds, so for many years, they didn't know to say a vulnerability was in C++ code. They would always say it was C code, right? So you'll see that C++, the numbers are probably lower than they really should be, and the C numbers are higher because a lot of security folks don't differentiate between those languages. So percentage-wise, at CERT, our vulnerability notes, which was a separate database, I think it was around 30%.
30%? Okay.
Yeah. And so it's also, sorry, there's more vulnerabilities in mom and pop web shops. There's a lot of cross-site scripting out there. The C and C++ vulnerabilities are more interesting because they tend to be in critical infrastructure, right? So that's important distinction. It's not just quantity, it's also quality.
And I'm going to break my own rule here. And again, Robert, you might want to address this as well as the panel and do a follow-up with this, because I think it's a very interesting question. That is, following up from the answer, how much of the latest hype is PR and also the C++ mix-up, conflating the two languages, and how much is due to real issues?
Yeah, I mean, there are real issues in C and C++. I've been a member of the C Standards Committee for nearly 20 years, and during that time, security's gotten worse. There's always a push from compiler vendors to create more undefined behaviors that allow for more, for more optimization opportunities, and the user community is underrepresented in standards activities. C, I know, because I'm there. C++, I suspect, as well. So on its own, things are deteriorating more than improving. So.
And the CERT database that you mentioned,
Yeah.
do you distinguish between vulnerabilities due to C and C++? Are they counted in separate categories?
Yeah, they get reported separately, but the people doing the reporting don't always.
They're unreliable reporters?
They're unable to distinguish between those things. Like another example is we would get a lot of buffer overflows, and then integer overflows would become popular, and then suddenly it was all integer overflows, right? And so, so the data is a little suspect. It's a little driven by what's in the news cycle and things like that.
Okay, thank you. So I want to get to the final question here, which I'm
I was
sorry,
just going
Chandler.
to try and actually respond there. I think that the conflation of C and C++, maybe it's wrong, maybe it's right. There's a lot of mixed code bases out there.
Right.
So I'm not sure it's that bad of a conflation. But I do think that, to be quite pointed at the C++ community, the C++ community's insistence on debating that conflation has caused more harm than the conflation ever could, because it is undermining the discussion with the security community. I understand that there is a distinction that we do want to draw sometimes, and that may even be an important distinction. But by focusing on this, it is causing really irreparable harm in how we actually communicate to the security experts, the security community, and to our users. And we need to not blame our users for not knowing the right terminology. We need to ignore that completely and figure out what their actual problems are, because I do think that for all that there is hype, it is hype motivated by very real, very pressing problems.
Right, okay. All right, so I think this will probably be our final question, and it's actually a very good question that goes to the reason why this conference was founded many years ago. So it's from Richard Saleh, and the question is, given JF's comments about the industry maturing, how will these changes affect open source and the employability of people without formal qualifications? If you don't have a hard physical engineering degree, the industry doesn't take you seriously, and the authorities won't let you drive the car you build at home. So I guess the question is, Boost is an open source library, right? And a lot of people do work in open source who are not necessarily engineers. How does this affect the adoption, I'm guessing, open source in industry, and how does it affect the discussion of safety and security?
Yeah, I'll answer the second part, not the open source part first. When I was a mechanical engineer in training, so not an actual mechanical engineer. In Canada, you can't call yourself an engineer. It's illegal. Or an ingénieur, because French and English, unless you're actually accredited as one. So I was a mechanical engineer in training. I was able to do every single thing that a regular engineer could do, except sign off on drawings. So all of the work that you do as a programmer today, if we were regulated in the same way as other engineering industries are, would be basically the same, except the person signing off on a drawing in mechanical engineering or civil engineering, in some countries such as Canada, is personally liable on their signature. That's the difference. Right? And it does mean that you have different responsibilities in the work that you do, but the programmer still programs. Just someone has to sign off on it. It's not just a sign off on, yeah, your code looks good, it's on the whole process that got you to that code. And again, in Canada, you are personally liable, not your company, you. And that's a big distinction.
You never do that. No one's ever going to sign off on anything, actually.
Well, to answer that, I mean, that's Tony out there, I think, so he probably wasn't serious. But
And yet, the software I run
but
today
yes, it's not just
is infinitely more
engineers,
reliable
actuaries,
than it was 10
accountants.
years
You get the certification because
compilers don't grasp
somebody who is certified is getting paid to sign off on it and take the risk. To say this is good and my name is on the line.
And that's where whistleblowers are critical, right? That's where you can stop the line and tell your management, we're not shipping this. Right now, if you go to your management and you say, I want to do a safety thing that is 50% more expensive, and I'm quitting if I'm not doing this because I'm personally liable, you don't have a leg to stand on, right? But if you're regulated and it becomes part of the regular way that the industry works, because you're in some form or another safety critical, not necessarily human life, but the livelihood of people or something like that, then it becomes normal to say these processes have to be followed. Like something as silly as using the wrong O-rings. Come on, like gets a shuttle exploded, right? And the whistleblowers would not listen to. That's a big deal. Imagine the similar events in software today. It's like, yeah, I didn't use all those things. I didn't write the right line of code. I just used the wrong integer type. It overflowed, and something happened. Like, right? That's the reaction you get today. And I think that's the big distinction. And I think you don't, yes, it's a personal liability, yet there are a tremendous number of accountants and lawyers and engineers, not computer science, but engineers in the world, because they care about the public good, and they have an ethical responsibility to do that. They take it very seriously.
So I might be the only one on the panel who's not, theoretically at least, an engineer. Lisa also, but I mean, I'm theoretically a chemist, or actually a theoretical chemist. Both, but and refused to call myself an engineer until I joined Google, to be honest. But I do think these are orthogonal issues, and I think it's actually important to recognize that the fact that the industry is more regulated doesn't mean that your contributions to visible code are less valuable. In fact, like it probably means that, number of engineers per line of code is going to, how did I phrase that ratio? There's going to be more engineers per line of code, meaning that the competition for high quality code is going to be higher, and so having lots of samples out there is going to help you more. So I do think that, maybe some open source code will be used less in industry. I don't know. I think there's enough industry that doesn't care about safety that this won't matter. But I do think that, keep contributing. I think it's very important. And I do think there are, all joking aside, I think there are plenty of viable pathways from non-engineering degrees to programming, software engineering jobs. And I think that every company represented here should be very serious about hiring those people.
Well, so just on open source, in safety industries, you can still use open source. It's just that any software you use has to have a particular context or be certified out of that context. And so if you just write open source software, you're not magically liable, I think, if the regulations are written in a way that makes sense, you won't be magically liable for that being used in that context, unless you've certified it out of context, and then you have to show that the processes you followed to get it certified, you actually made a professional mistake in that certification. And so there is a path where open source software authors can also sell a certified version of their thing out of context or for particular contexts and still have a viable livelihood, right? So it's not dire for open source. It's a change for the person who integrates that software into a critical infrastructure. Like, if someone builds a bridge and goes and takes like a random bolt that was not built for a bridge and puts it in a bridge and the bridge falls because of that bolt, it's not the bolt's person's fault unless they misrepresented their bolt as being certified to be used on a bridge, right? It's the same with software, yeah.
No, I'm saying we have standards not for concrete. We have standards for concrete too. Anyway, we have standards for concrete in a building of above 30 floors. We don't have standard for concrete. We need, I'm not sure that we're addressing the problem correctly. We don't need to fix the language. The language is just the concrete. We need to, in my opinion, maybe avoid the safety issues on the target side. I think
right, but I think right now, languages make it fully the developer's responsibility to have as much security and safety as the language allows them to have. So it's a trade-off where some languages like Swift or Rust could make it easier on the programmer's job to have better safety and security or make it easier to get there or have tooling that allows you to get there.
So just that, I just want one more short comment. I think that maybe our focus should be on our users. What we want to have is allowing the users to write safer software easier and not necessarily fix our software in the sense of technical, correctness. So, I mean, because at the end goal is to get to a safer software, to have a more, safe software in the world, which the only path for that is to actually, have our users. So yeah, that's basically what I wanted to.
Let's take a question from John, and then Marshall, and then we'll
Yeah, I mean,
have
I
some
would.
closing comments.
I think there's a really important thing to say here, which is that like in regulated, like if you're an engineer, right, like, you would never design a bridge that is wholly responsible, that that puts the entire weight of the bridge on one bolt, right? That's not a responsible, that is an irresponsible bridge design, right? Like the way that you design a bridge that stands up is that there's like layers and layers and layers of things that like make the design work, right? And one part fails and another part of the bridge like compensates for it, right? And I think there's a very direct analogy here with software safety, which is that like, yeah, we can make, like users should be more responsible. Users should not, I mean, it's one thing if you're, like running doing your high performance computing simulation, right? If you take the same software and like run it on a device, running user code through it in an AI, right? And there's user data there and you can expose it if there's any bug, right? Then like all of a sudden you're not being responsible anymore, right? Like, and there's a lot of audio code that like, there's audio processing code where, it's just running on some compute farm and if it crashes and you'll rerun the job. There's also audio code that's like codecs. And if it crashes, then it corrupts the entire device and your device is owned, right? So like, I guess I'm saying that like, sure, we can ask users to be more responsible about these things, but like you can't just solve it at one layer. You have to be more responsible at every layer in the process.
And just if you were trying to
partially.
Yes, I just want to clarify. My intention wasn't to educate the users. My intention was to actually make it easier to do the right thing, maybe with defaults, for example. I'm not dropping this on the users in any way. And I just want to say, like, so, I mean, at least in my mind, if our end goal is to be safe for, the world, to have the world see us as safe, then maybe we also need, maybe we need to acknowledge that and also be able to have some of the things that other languages have ported into our language. Maybe that's the only way to actually achieve that goal, because, I mean, if, let's take it as axiom that, the safety, let's assume that they know what they want. Maybe we just need to try to achieve what they want, and that would also classify as safe. Because we can't fight it, right? Like, we can't, in a way, we've just agreed here that we aren't able to identify what exactly we're missing, but we're definitely missing that. So.
Okay, any
Anyway.
comments on that? Anybody? Okay, Marshall had a question or a comment, and then well, it's Marshall.
So I have a slightly contrarian viewpoint here. I'm going to dig up some advice from 20 years ago. Does everybody remember the phrase, save early, save often? Yes. Does everybody remember, oh, your Windows machine, you should reboot, you should turn it off every night, or reboot it every 24 hours because it becomes more reliable? Yes. I've worked with browsers that you load a web page, crash, oh well, you just relaunch it, reload the same web page. None of that happens anymore. Lots of people have put lots of effort into making software more reliable. It's not less reliable today than it was 20 years ago. It's more reliable. And we've had 3 hours of doom and gloom here, all day mostly. And you know what? These are real problems. But we want to not lose sight of the fact that things are getting better. They're not getting worse, they're getting better. I have machines that have run for 2 years without any problems. Anyway, I'm done.
Lisa?
I'm going to point out that there are two components of risk. One, the probability that things will go wrong, and that has been getting better. The other side is the damage that is done when they do go wrong. And that has been getting worse because software is just more important than it used to be. And that's why we actually have to step up our game.
Herb?
Yeah, I was going to add to that, which is the other part of the equation is, I got to steal it on the way by, is that it's I used to have one computer. Now I can't count the number of computers I have. And so, and I mean that in the sense of everything I have. My refrigerator has a computer in it. And so I don't have to reboot my Windows box once a day, but once a day I have to reboot something. My watch, my phone, right? Some system, my security camera, right? The mean time between failure, hasn't improved that much just because there's so much stuff.
I agree with the previous two. So you're making a good point, Marshall, but another distinction I would draw is Murphy versus Machiavelli. So we are better at things not falling over. What is different and new and super urgent is attacks by determined enemies who aren't always trying to take down your machine. In fact, their attacks work better when your machine keeps running and doing what they want. And you don't even know that your router's been compromised, that your fridge has been compromised, that your smart light bulb, we have way too many of those, have been compromised. And so what you said is true, but I don't think it's directly applicable. And it's great that things have gotten better for Murphy. There are way too many well-funded Machiavellis in the world, and it takes less funding than it used to, and they're doing more damage.
I spent 5 years in the product security group at, shall we just say, a large company whose name starts with Q, who does cell phone technology. Trust me, we knew we were a target for several nation states. So yes, I'm very familiar with Machiavelli and all those things.
I mean, I do think the optimism has been lacking from this whole discussion. I do want to agree there. Like we have learned to build systems at scale that are unimaginable 20 years ago. right? And so like that's part of why we're having this discussion is also the scale of software.
We're victims of our own success.
Exactly.
In some sense.
And so like there is a happy version of this that like we've graduated from C++, right? I mean, it's a joke, but it's not a joke also, right? Like, and this is really cool because it means that we're on the verge of needing something new and we all get to be a part of it. So like, I think there's a lot of doom and gloom because of the consequences of these things can be like really, really sucky. And there's some optimism that needs to be in place here too, for sure.
Chandler, I'll let you have the last word.
I promise it's going to be
I
optimistic.
might regret that, but
The thing I wanted to say is like I think people maybe missed that I actually made a very optimistic comment, and I do agree with Daisy on the optimism thing here. Remember when I said that, right? Like we say there's an existential threat, but it's nowhere near us, right? And I talked about all these lead time things. I just want to point out the math. Like we shouldn't be pessimistic about the presence of C++ successor discussions taking place that are going to try and address, no matter how difficult, they're going to try and address these like potentially existential threats right now. We should be optimistic because we're talking about them now. Sure, they're in their infancy. We have a decade to figure this out, right? Like we are getting started growing up and we're looking at all of these different things. And so I also think that in addition to this being a kind of a success disaster in some ways, I also think that, the tension and like some of the challenging things we're talking about are actually us recognizing a long-term problem and beginning the long process of addressing it.
yes.
And we might actually be doing so in time, right, if anything. And so I don't think we should be sad about this. I think we should actually be kind of excited that like, no, like cool, the language and compiler people are actually thinking about this on a time horizon where it might even be useful to us, right? That is actually a really awesome thing. That's not a bad thing at all. And so to that extent, I think that these are great signs that C++ has a future. We don't know which one. Herb and I might disagree about which one, but like there is active investment in figuring that out, and I think that's actually really awesome.
Okay, on that note, I've got 2 quick comments to make. First, next time I host a panel, I'm putting Sean on the end. And secondly, thank you very much. We went half an hour over. You've been great. Thanks, everybody. Good night.